So an assumption that we make here always is that the population is normally distributed. In other words, we did not collect data from a skewed population. If that happens, then whatever that we're about to do is completely wrong. So, in the problem, they have given us the claim value of alpha, x bar from some sample, standard deviation from some sample. That is the sample size of said sample. 25. Based on that, what type of test are we about to perform? Left, right, or two-tailed? Well, I would say we have to write the definition of the test first so that we can understand it better. So, null, alternative. Where should that statement go? Mu greater than or equal to 8,000. The null, why is that casting? No, is it?
Because it has the equal sign.
Because it has the equal sign. So if the null is mu greater than or equal to 8,000, what is the alternative?
Plus
Mu less than 8,000. In this case, the claim is in the null. And as I mentioned last time and the time before, this is pretty unusual in practice where we have the claim in the null. We always test for the alternative, but some do it this way, but it's highly uncommon. So the next step is to compute the test statistic. The test statistic is a simple t-score, x bar, the mean, minus mu naught, divided by s over square root of n. That is the formula. You might wonder as to what mu sub 0 or mu naught is. It is the mean that is in the plane. So our reference value. What is that reference value in our problem? It is 8,000. So the sample mean (7,700) minus 8,000 divided by 450 over square root of 25. Did I do my math right? You're right. It is 3.3. So the purpose of the test here, again, is to look at the sample mean, which is 7,700. And we're going to test for mu greater than or equal to 8,000. Obviously, is the sample mean, is the population mean greater than or equal to 8,000 based on the sample? No. But In this case, it is a trivial example. But we still did the test. 0 is going to be right in the middle. Where should the rejection region be? Left-hand side or right-hand side?
Left.
Left, because this is a left tail test, pointing to the left from last time. We have to find the critical value. What do we use to find the critical value? Inverse T. So in our case, alpha is 0.05 or 0.01. N is 25, so 25 minus 1, 24. That tells you what you need to put in the calculator. Inverse T, 0.01, 24. And what is that number?
Negative 2.492.
So the critical value right here is negative 2.492. And that is our test statistic. Where would that fall on the real number line that I have up there? Could it be here?
No.
There, there, there.
Reject.
So should we reject the null? Sorry. So negative 2 point, sorry, negative 3.33. So negative 3.33 is less than negative 2.492. So we reject the null. If we reject the null, we're finding evidence toward the alternative. So is the claim true or false? False. So the data is providing evidence toward the alternative. The claim is in the null, so we have no support to the claim, so the claim is false, yes.
So do we always use the alternative to find out which way the tail is pointing?
Yes. So as I mentioned last time, look at the sign, it's going this way, left, that way, right. Not equal to two sides. Okay, so the claim is mu less than 4,950. Where should we write this? Over here or there? No alternative.
Alternative.
Because it doesn't have an equal sign. So what is H naught?
Greater than or equal to.
And in our case, the claim is alternative. Really alternative. What is the value of mu naught?
49.15.
So the sample mean is 5,070 minus 49.15 divided by 5,630 over square root of 51. When you evaluate this in the calculator, make sure you put parentheses. Numerator as well as denominator. What do we get?
0.1298.
Close to 0.
0.1298.
Point 1298. Is this a left tail test or right tail test? Right. Well, make up your mind, is it a left tail test or right tail?
That's the left.
It's a left tail test, pointing to the left. So the critical value is t sub alpha comma n minus 1. So t sub 0.02 comma 50 and inverse t 0.02 comma 50. And what do we get?
-2.109.
So the critical value or our position line is right here, and the test statistic is 0.1298. Where does that lie? Right over here. Should we reject the null? No. Is the claim true? Yes.
No.
Make up your mind this. The claim is not true because we did not reject the null. We did not find any evidence that would support the claim. So the claim is not true. Are we clear?